Okay, hi, we're going to talk about negative exponents, and the most important thing here to understand is that exponents tell the base what to do, period, and that's it. It's just telling the base what it's supposed to do. And an exponent is telling a base how many times to multiply it by itself. So, meaning if I have 4 cubed, it is 4 times 4 times 4. You write that in the calculator, and you'll get 64. Okay? Now, you've only ever dealt with, I'm presuming up to this point, is having a positive exponent, or you've had negative exponents and no one's ever told you that the proper notation is not to leave something in negative exponential form. It should always be positive exponential form. So, what we understand is that the exponent tells the base what to do. Now, an exponent tells a base how many times to multiply by itself, okay? If I had 4 to the negative third, thinking about this and just applying it as just that an exponent tells a base what to do, this would imply that negative 3, number sense-wise, is a number less than 0. So 4 to the negative third would be like me saying, hey, multiply your base by itself less than 0 amount of times, which doesn't really make a whole lot of sense. So the negative exponent doesn't mean how many times you should multiply it by itself. What does mean how many times you should multiply it by itself is still the value of 3. The negative value just simply means that it's in the wrong place, or it should be going the opposite place, okay? And what I mean by that, and I'll relate this all back to a number line very quickly here, okay? So, back to a number line. Everyone knows the basic number line has 0 in the middle, and every value to the right of 0, we say that is positive, correct? So what I want to associate here with you is that in pure mathematics, okay, a negative is direction, and that's it. It's just simply direction. And it has nothing to do with a value amount or anything like that, and that's absolute value plays a big part in that, and I'm not going to get into that, but negative is literally a direction in a pure mathematics problem. And thinking about that, okay, if I came up to you and I said, hey, plot the point 4, you would go to 0 and you go 1, 2, 3, 4. You would go 4 equal units away from 0 to the right. Because positive we associate as going to the right, yes? Which means starting at 0, we're just going to count like normal. So, the minute I say to you, so here's the 4, let me plot that very quickly, but now I say to you, hey, I want to go negative 4. Well, I'm not changing the amount that I'm moving. I'm still going to move 4 equal increments of 4, okay? But I'm just changing its direction. Meaning instead of being on the right side, I want you to be on the left side of 0, 4 units. So it's not changing an amount of anything, okay? Because it's still saying to you that you are still 4 units away from 0. It's just you are 4 units left of 0, whereas positive is 4 units to the right of 0. And that's what I hope you understand by when I say negative is just simply a direction in a pure mathematics problem. Applicational is a little bit different. Okay? Application means that you're owe money or something of that sort. But a pure application of math problem, it just simply means, a pure math problem, it just simply means that it's direction. So instead of being to the right, it's saying, hey, go the opposite way. So, that's the kind of concept you have to take into this negative exponent. The negative exponent is just saying to you, hey, I know that I have this base, and now that I've put a negative exponent on it, I just want to let you know that I've done my work in this area, but the answer needs to be in the opposite area. So, what do I mean by that? Let's take a look at a couple quick examples. So, going back to this 4 to the negative third, okay? All numbers can be written in ratio form, okay, except for irrational numbers. So all rational numbers can be written into fractional form. And what we're going to deal with is properties of rational numbers right now. So this is a rational number, so therefore it can be written as a fraction. And 4 written as a fraction is 4 over 1. So, we're basically starting off a problem with saying, hey, you're at the end of a problem and you've come up with this answer, it's 4 to the negative third power. Well, remember, you're still going to have 4 multiplied by itself 3 times. So, I still have a 4 that I'm saying multiplied by itself 3 times. What you need to understand here is that this work, okay, this answer is currently in the numerator. So 4 to the third power, which is the negative, symbolizes that it's in the wrong spot. Remember, negative N-O. So alphabetically, N-O, no. M-N-O-P, you know what I mean? N-O for no. Negative, not a good spot, okay? So what I'm going to do is I'm going to circle it with its base and just say that, hey, it needs to go to the bottom. So what I've got here is that this answer becomes, there's my fraction bar, 1 times 4 to the third. And when I put it in its right place, okay, I make it positive because positive means right place. And if you think about the number line, right, okay, of the 0 is positive. Okay, so just kind of like making a little word connection really, is that if it's positive, it's in the right spot. If it's negative, it's in the wrong spot. So now, if I took this and I moved it to the bottom, well, what goes up top? Well, if you ever remove something from a fraction and you move its entirety, there is still always a 1 there because 1 is being multiplied by everything and everything at all times. So what I get left here is 1 all over, and I don't need to show this multiplication of 1, it becomes redundant. And I get 1 over 4 cubed. Now you can leave it as that if the problem says leave an exponential form, but if it says simplify, you must write out what 4 cubed is, and I would just type in my calculator 1 over 4 cubed, okay, and you'll get 1 over 64. Or you can just type in your calculator 4 cubed, get an answer 64, and write it over 1, okay, underneath 1. So you get 1 over 64. So that's just using a basic number problem, which is saying to you, hey, it's just in the wrong spot, it needs to move the other. So let's look at some laws with bases that are numbers with variables. Okay, so what happens if I have 4x to the negative 2? So now I have this number says 4x to the negative 2. What I need you to understand here is that every single thing, every little thing now has its own little exponent. So this is 4 times x to the negative 2. It is not 4x to the negative 2. Okay, the exponent of negative 2 is just strictly on the x. So this, I'm going to circle on the x and go, okay, here's my fraction bar. Instead of being a numerator, it needs to go to the denominator because the negative tells me it's in the wrong spot. So the 4 stays up top, and I'm left with x squared. And then that's that simple problem. So let's do something a little bit more. So what happens if I have something like 5x cubed y to the negative 2? So now I just added more to it. Okay, the thing we need to remember here again is that I'm just going to look for the base that has the negative. 5 is a base. It's a number, but it's also a base. Because if it had an exponent, then the 5 would be whatever it is. So this, I circle the thing with the negative. I'm going to draw my fraction bar, and it goes to the bottom. And the reason it goes to the bottom is just because it's in the numerator. I don't want you to associate always moving negatives to the bottom. And I'll show you why in a second. So I get 5x cubed all over y squared. And that's the final answer. Let's do one more here. So let's do something with 4x to the negative 3, y squared all over z to the negative 3. So here we go. What this problem states here, okay, is the same exact thing. You're just looking for the negative exponents, and that's all I need to look for at this point. Because if I'm dealing with a problem that says simplify it, making it not negative, I'm just going to look for where are the negative exponents, and those are the things I'm going to look for. So in this particular problem, I have 4x to the negative third y squared. So I have an x to the negative 3 up top. And then in the denominator, I have z to the negative 3. So all I'm looking for here to do is I'm just going to take the things that have negatives and move them to the opposite spot. Since I'm dealing with a fraction, there's only up in the numerator or the denominator. So the negative 3 with the z goes to the top, and the x goes to the bottom. And my final answer here is 4y squared z cubed all over x cubed. And notice when I moved them, I made them positive because positive means it's in the right spot. So I hope you understand that with the negative exponents a little bit more. But a negative exponent just simply means you need to move something that's in the numerator to the denominator and something that's in the denominator to the numerator.